Steel Dome Air Defense System. The Steel Dome Air Defense System is defined as a multi-layered, network-centric air defense architecture developed by Turkey with domestic and national capabilities, and described by the Turks as a system of systems. The purpose is to detect threats at low, medium, and high altitudes, UAVs, cruise missiles, ballistic missiles, short-range rockets, conventional aircraft, and new FPV-type drones in an integrated way from a single center. And after identifying whether the target is friend or foe, activate the appropriate layer to neutralize enemy elements. This system was developed to reduce dependence on foreign countries and to protect the national airspace. Looking back at past years, the military embargoes imposed by Europe and the United States made the Turks more meticulous in this matter. During the Syrian civil war, Turkey was exposed to missiles and rockets launched from Syria and requested an air defense system from NATO countries. However, at that time both Europe and the United States made excuses and did not provide Turkey with the American-made Patriot air defense system that was in use at the time. It seems that the Turks learned a valuable lesson from this situation and produced the world's first multi-layered air defense system. What is meant here is an air defense system in which even the smallest air element is included, and which, in their words, has been turned into a system of systems. Let us now take a closer look at this massive structure called the System of Systems. The Iron Dome system was approved at the Defense Industry Executive Committee meeting held in Ankara on August 6, 2024. The contractors in this project are Aselsan, Roketsan, Tubidic Sage, and the Mechanical and Chemical Industry Corporation, MKE. It is a complex and multi-layered system. Main question here is, did the Turks accomplish this in only 2 years? How did such a complex structure get built within 2 years and delivered to the armed forces on August 27th, the day celebrated as Victory Day in Turkey? In fact, the infrastructure of Turkey's defense industry companies had been prepared for about 20 years for this system. Subsystems such as camera systems, infrastructure systems, rocket systems, and radar systems were artificially initiated by the Turkish defense industry about 20 years ago, especially in areas where Europe and the United States had imposed embargoes. Aselsan's general manager, Ahmet Akyol, stated that the products developed in this context are specifically those that were under embargo in advanced high-tech systems. Among the products produced by Aselsan are communication systems, radars, avionics, electronic warfare systems, air defense systems, and targeting systems. If we look even further back, Aselsan was established in 1975 after the Turkish government launched a military operation on the island of Cyprus when the Greeks began massacring Turks there and captured half of the island. The Turkish government, heavily sanctioned by the United States and Europe at that time, decided to establish a company like Aselsan. Today, the company sells military equipment to 93 countries and ranks 43rd among companies producing military equipment worldwide. In fact, one should not be misled by its 43rd place, because nearly more than 30 of its rankings consist of American ranks. In other words, Aselsan is at a very advanced level of military equipment production. The company, which celebrates its 50th anniversary this year, plays a major role in the development of the Iron Dome air defense system. If we summarize the main contractors and their responsibilities, Aselsan serves as the main integrator of the project. It develops command and control software, artificial intelligence-supported decision support systems, and architectural solutions that enable communication between all systems in the field. It is also involved in the production of components such as radars and electro-optical sensors used in the system. In short, command and control, radar, communication, and artificial intelligence systems are Aselsan's responsibility. Roketsan, the main contractor developing air defense missiles and systems. It produces short, medium, and long-range air defense systems such as ALCA, laser-supported directed energy system, BERT, Sungert, Levent, HİSAR, and CLPM. TÜRKİYE SAGE conducts the engineering, prototype production, testing, and development processes of the Iron Dome air defense system. It also contributes to the development process with domestic air defense missiles such as Gikdogan and Bozdogan. MKI takes part in infrastructure works such as close air defense systems, rockets, and ammunition production. The president of the defense industry, Haluk Gürgen, announced that approximately 500 subcontractors, SMEs, and technical personnel contributed to the project under Aselsan's coordination. In addition, university laboratories, SMEs, and the subcontracting industry also play an important role, particularly in terms of localization rate and SME participation. Let's now examine this multi-step layer. This system consists of a total of 3 layers: low altitude, medium altitude, high altitude. Now, let's first look at the low altitude. In the Iron Dome architecture, low altitude is divided into very low altitude and short-range air defense. The lowest layer is designed to stop targets such as mini and micro UAVs, FPV kamikaze drones, low-flying helicopters, and cruise missiles with a very short reaction time. CUS, anti-drone, consists of close air defense guns, munitions, lasers, DO, and short-range missile solutions. Now let's look at the main elements of this layer and their technical roles. Soft kill CUS, jamming, deception, detection tracking. Aselsan ETAR 100 detects, tracks, and neutralizes mini-micro UAVs in urban rural areas through jamming. It has fixed and mobile configurations. Multiple sensors and RF GNSS jamming components can be integrated. Its most critical function is to disable the threat before firing at it and to slow down, disrupt the engagement chain. Hard kill CUS, short-range air defense guns with airburst munitions. Aselsan Kahiyen 130/40th GL, 40 millimeters. About 700 meters effective range against mini-micro UAVs. It receives target information from radar in EO, automatically orients, and performs physical destruction with high-speed airburst ammunition. It is a point defense system for critical facilities and bases. B. Aselsan Kar, Korkot 110/35 S, 35 millimeters. A single-barrel 35mm system against very low-altitude threats for fixed facilities and border regions. The system's ammunition is a TOM 35mm fragmentation, airburst munition. It has a wide target set from mini UAVs to helicopters. C. Directed energy, DO, laser and electromagnetic. Rockets and ALCA, yes, hybrid architecture. First, it forces the UAV to fall with electromagnetic jamming, soft kill. If necessary, it physically destroys the target with a laser weapon, hard kill. It has fixed, portable, and vehicle-mounted mobile configurations. It is a cost-effective layer, especially against FPV swarms. The Aselsan Gokberg mobile laser weapon system operates on a 6x6 vehicle with radar, EO reconnaissance surveillance. It is a system capable of physical destruction with a laser greater than 5 kilowatts. It also has the Kangal jammer on top, providing soft kill capability. Provides moving base, convoy protection against FPVs and mini UAVs. E. Short-range missile, man pads, low altitude, outer ring. Rockets and Sunder, shoulder-launched man pads and suitable for vehicle trench-leg turret integrations. With a range of more than 8 kilometers and altitude close to 6 kilometers, equipped with IR seeker and fire and forget capability. Provides maneuvering unit escort defense against helicopters, UAVs, and cruise missiles at low altitude, creates an overlapping intersecting ring with close-layered gun laser systems. Now, if we make an intra-layer task distribution in this low-altitude air defense system, detection and suppression, soft kill, HİSAR, Gökberk, and ALK's jamming channels undertake this role. They disperse FPV swarm raids and gain time. Physical destruction, hard kill, Kahian 40mm and Korkut 35mm. Strike small targets at low cost with airburst munitions. Any escaping targets are completed by LK Gökberk lasers. Outer ring short-range missile. Sungur intercepts more distant hard targets such as approaching helicopters or cruise missiles in the outer ring. Thus, it reduces the load on the inner ring gun laser systems. In the Iron Dome air defense system, these systems are used in the low altitude. Now, if we examine the second layer, the medium altitude air defense system. In the Iron Dome literature, when we say HİSAR medium altitude, it is generally considered as the altitude band between approximately 3 kilometers and 15 kilometers. The maximum altitude that the HİSAR family can reach is given as 15 kilometers. Therefore, within the Iron Dome, medium altitude is almost the operational area of HIOF. Now let's see what kind of threats are targeted at this layer. These are fighter aircraft, attack aircraft, helicopters with low-medium approach profile attacks, cruise missiles and medium-altitude cruise, especially standoff types, medium-altitude UAV types, tactical UAVs, and some fast cruise-type unmanned systems. Another part targeted at medium altitude is fragments from incoming targets fired with standoff missiles and some non-ballistic high-speed targets. This threat diversity means that the medium altitude layer must be flexible against both fast-passing air targets and slow but low-signature cruise threats. If we examine the detection, sensor, structure, 3D AESA, phased array search tracking radars. Examples include Aselsan Kalkan and Kalkan 2, mobile X-band A ESA architecture, hundreds of target tracking, instrumented range of about 100 to 120 kilometers, and coverage area of 360 degrees, with LPI-EW defense modes, form the main search tracking layer for medium altitude targets. The Kalkan family vehicles form the sensor backbone of medium-range batteries, such as HIOISA, EOIR, target designation and electro-optical tracking packages. When the radar-cued target approaches, EOIR provides confirmation, classification with thermal signature, and target reference for terminal sensors. In the HİSAR architecture, it works together with EOIR vehicles. Passive sensors and signal detection, for example, PUHU, provides early warning based on RF emissions, direction finding, EF, and command control data transmission. This passive network complements radar against LPI hard-to-detect targets. F command control, fusion, and decision support. Harry KKS Hakim Type C4I merges tracks from radars and sensors in the field to create a common air picture, track fusion. Manages threat prioritization, weapon assignment algorithms, and mission planning. In the Iron Dome, this layer has been developed with a IML-supported decision support. Features: Herix manages command control tasks from battery station level to wider levels. This architecture reduces latency through automatic data sharing between sensors, Kalkan, PUAO, and weapons. F ammunition weapon elements, medium altitude strike elements. HİSAR and HİSAR were developed by Roketsan. They are members of the medium altitude SAM family. If we look at the technical highlights here, vertical launch, dual pulse solid rocket motor, terminal IR infrared imaging seeker. In the O+ variant, RF seeker, multi-mode seeker integration is present. The range and launcher configuration includes 6 ready-to-fire missiles per vehicle, with multiple launcher vehicles at the battery and regiment levels. HİSAR is designed against fixed-wing aircraft, helicopters, cruise missiles, and UAVs. Moreover, coordination with the higher-tier high-altitude air defense system is maintained, and medium-altitude targets are protected in an overlapping zone with SİPER, i.e., the high-altitude air defense system. It should be noted here that while HİSAR is a localized solution, SİPER provides strategic, very long-range air defense and strategic superiority. G. Engagement chain, detection strike, technical flow stages. Early warning passive detection is carried out by PUHU or Kalkan radar, generating the initial track. Track fusion and classification. HERA-KS Hakim creates the common track picture. IFF and EO, IR, are used for classification. Threat prioritization and weapon assignment. AI-supported recommendations with human approval, according to ROE. Determine which battery fires how many missiles. Launch and guidance. After launch, HİSAR is corrected in mid-course guidance, INS plus data link. In the terminal phase, the IR RF seeker locks onto the target, and the warhead plus environmental effects destroy the target. G. Electronic warfare, EW, and countermeasures, defensive ECM. PUHU VUHM finding. High-speed spectrum scanning. Reddit radar ease AI. Systems detect and geolocate enemy radar, communications emissions, and when necessary, apply jamming, deception, electronic attack. This layer provides soft kill support by detecting cruise, missiles and emission-based targets, and feeding HİSAR and radars. The medium-altitude architecture seeks resilience against ECM by using multi-sensor fusion plus multi-mode seekers IR plus RF. Additionally, radar LPI modes, frequency hopping, angular scan variations, and data fusion are part of ECCM techniques. J. Distribution and platform details, operational structure. Systems like HİSAR form operational batteries with mobile chassis deployment vehicles, such as radar vehicles, EO/IR vehicles, and command vehicles. Kalkan radars are deployable and mobile. This provides the medium-altitude layer with dynamic deployment and relocation capability based on mission needs. In summary, if we explain the medium-altitude air defense system in Kelik-Kop, it functions in this way. In fact, all these systems are tightly interconnected. Now, let us examine the last layer, the high-altitude air defense system. If we talk about the general objectives of Turkey, developing a high-altitude air defense system to protect Turkey's critical cities, industrial facilities, military bases, and nuclear power plants against ballistic missile attacks. These include medium-range ballistic missiles, long-range ballistic missiles, and even to some extent, intercontinental ballistic missiles with nuclear warheads. On the other hand, it also operates against hypersonic cruise missiles and high-altitude air-breathing threats to provide an umbrella air defense compatible with NATO integration. Looking at the technical specifications at high altitude, altitude coverage ranges from 20 kilometers to 120 kilometers, with exo-atmospheric interception capability targeted. Engagement range spans 150 kilometers to 800 kilometers. Radar coverage offers 360 surveillance with ballistic missile detection out to 1,000 kilometers, which is an extraordinary radar performance. The reaction process ensures engagement within 2 to 5 minutes after ballistic missile detection. Main system elements: long-range radar network, Aselsan EIRS, early warning radar system. With a 600 kilometers range, AESA radar has a very critical and strategic role in ballistic missile detection. Additionally, space-based satellite intelligence via Gate-Türk series satellites plus new early warning satellites. Command and control. Havelson's integrated air defense management and software, a system controlling layered defenses from a single center, which requires extraordinary integrated software, a truly complex task. High-altitude interceptor missiles. Not all are fully operational yet, but the project has passed prototype phase and is expected to enter serial production next year. Currently, SİPER Block 1 has entered mass production. With this series, the aim is to match the S-300 and Patriot systems. But with Block 2 and Block 3, exo-atmospheric interception is planned, essentially developing a DAAD equivalent system capable of intercepting ballistic missiles outside the atmosphere. This system is expected to enter service next year, a remarkable development for Turkey. The contractors for this system are Roketsan and TÜRKİye Sage. To summarize, SİPER Block 1 and 2 provide medium and long-range air defense, while SİPER Block 3 will serve as the ballistic missile interceptor for high altitude. The truly remarkable part is that all of these systems will be controlled from a single command and control center. Operationally, the high-altitude system functions as follows. When there is a ballistic missile threat, enemy missiles are first detected, mainly via EIRS radar. Then data is transferred to the command center. The threat trajectory is calculated. The appropriate interceptor, whether SİPER Block 1 or 2, is launched. However, when faced with a hypersonic or high-altitude threat, AESA radars or AI-supported systems come into play to track the target. Then SİPER Block 3, the exo-atmospheric missile system, is launched, which is reported to enter service next year. In conclusion, if we evaluate this extraordinary system overall, we can easily say that it is one of the most advanced and secure air defense systems in the world. Of course, it is not yet fully ready, but considering that SİPER Block 3 is planned to enter Turkey's inventory next year, it will become the most advanced air defense system globally. The reason is that from the smallest mini drones to intercontinental missiles, and from nuclear warhead-carrying missiles to hypersonic missiles, all are managed from the same central command system. Looking at other countries, such as the US, Israel, or Russia, leaders in air defense, all have separate systems that cannot be fully integrated, meaning threat comparison is not conducted. Taking the Russia-Ukraine war as an example, most casualties have come from FPV drones. That is, while ballistic missiles are strategic, small drones often considered insignificant have changed the course of war, causing more destruction and soldier deaths than even intercontinental missiles. And systems that treat them separately either fail to detect these drones or end up using multi-million-dollar ballistic interceptors against very small drones. For instance, during the Iran-Israel conflict, Israel used the interceptors against very small missiles, with reports showing that the stockpile of U-supplied VD missiles was nearly depleted. This resulted in an ineffective and extremely costly air defense. However, Turkey's AI-supported central command system distinguishes threats ranging from small drones to ICBMs, determining with AI which is most effective, activating the most appropriate layer, and neutralizing the target. This radar system is reported to be effective for targets from above the atmosphere down to below 1 kilometer. Thus, both effective air defense layers are activated and the most economical system is operated. For example, a simple cruise missile would not trigger the ballistic defense layer as Israel did. Instead, the medium-altitude air defense layer intervenes more effectively and economically than the high-altitude one. Yes, friends, this is as much as we can explain Turkey's Kub air defense system, which has gained wide coverage in the world media. The system is extremely detailed and consists of many defensive elements. From a geopolitical perspective, Turkey has developed a very strategic and effective defense system in today's world, where regional wars erupt almost daily. This is a geostrategic move that will shift dynamics, particularly in the Middle East. Considering Israel's aggressive stance and serious provocative actions toward Turkey, this strengthens Turkey's hand significantly. Looking at the defense industry equipment Turkey has produced in recent years, all are shifting from 20th century weapon systems to new AI-supported, economical, yet highly effective 21st century warfare systems. It seems that Turkey is regaining its strong place in history. Geopolitically, given Turkey's strategic location, it looks like the country will once again greatly influence the world, as it did in the past. That's all for today. We'll meet again in another discussion of systems and equipment that shape geopolitics and geostrategy in the New World. If you enjoyed this and want more videos, don't forget to follow and like. Goodbye.